the only difference. All right, guys, this one's quick.
Yeah, and easy.
Yeah.
Kind of just
Yeah.
common sense, really.
Yeah, and we're skipping a couple sections.
Yeah.
Not that we wouldn't have told you that in class already, but we are skipping 3.4 and 3.5. It's stuff that we're going to do later. It's kind of a review of Algebra 1, and you did it to death in Algebra 1, and so we're just going to pass that up for right now.
Yep.
So this first slide is very similar to what we've been doing. The second slide is new.
Yep.
But that's it. We only have 2 slides, I believe, in this, and so same thing.
First one is a perpendicular transversal theorem, and I'll read it and then I'll kind of give you my shorter version of it. It says if a transversal is perpendicular to one of 2 parallel lines, then it is perpendicular to the other. So, I mean, really, if you have a set of parallel lines and the transversal makes one of them a perpendicular, well, then you know the other one's a perpendicular. That's just kind of the way it is.
So you got to catch that you have to be given 2 things. You have to be given 2 lines are parallel.
Yep.
And you have to be given that the transversal is perpendicular to one of them.
Yep. You need to see the package or 90 degrees or something like that.
But it goes back to all of our rules.
Yeah.
You could do corresponding angles, you could do alternate exterior angles, you could
Yep.
do all kinds of things to see that those lines end up being parallel.
Yep.
So it's just a 90 is all.
Yep. That's all it is.
Okay.
It's kind of the converse, right? No.
If 2 coplanar lines are perpendicular to the same line, then they're parallel to each other. No, it's a little different. If we have, this is called lines perpendicular to a transversal. So if we have 2 coplanar lines that are perpendicular to the same line, so it's kind of opposite of that
Yeah, it's
in a
converse.
way.
Yeah.
We have, instead of being given 2 parallel lines, we're given 2 lines that are perpendicular to the same line.
Yep.
Then those 2 lines that we were given originally must be parallel to each other. It makes more sense if we have a diagram.
There you go.
So if we know that M and N, if we know that M is perpendicular to P, and we know that N is perpendicular to P, then M and N have to be parallel to each other. That's what it is specific to that diagram. So if we're given that each of those 2 lines are perpendicular to line P, those 2 lines have to be parallel because they end up with right angles.
Yeah. Or you could go back to corresponding angles right there and say, since I know that N is 90 degrees because of the package, and I know that M is 90 degrees because of the package by the rules of the alternate or the corresponding angles converse, we know that those 2 lines are parallel.
Right.
Okay.
So this is not a major leap here.
Nope.
Really, it was doing what we were doing before, just with 90-degree angles is all, right
That's
angles.
right. That's right.
So, but this is new though.
Yeah, this one right here is new.
Yeah,
And this is a distance from a line, and this one's kind of important because
it's very important.
we use, when you're trying to get somewhere, the quickest, the shortest distance between 2 points is a straight line, and you got to remember that straight line part is by a perpendicular,
Right.
not necessarily a straight line to something. It's got to be from a perpendicular kind of idea.
Well, especially when you're talking about this, where we're talking about the distance to a line. We're not talking about the distance between 2 points. But it ends up being that.
Yeah.
And that's what I always talk about with this. Shortest distance between 2 points is a straight line. But we could have a straight line at some kind of weird angle.
Right.
But that's not necessarily the shortest distance. And
Right.
so this is saying from a point not on a line. So notice that A is not on the line K. The distance is, that's the definition that we're defining here, distance. The distance is always the shortest distance. So the distance is the length of the perpendicular segment from the point to the line. So if we draw that perpendicular segment in, that's what's defined to be the distance. Now I know there's other distances. You could go A at some angle over this way. You could go A over towards that K over there. You could go all kinds of different angles, but because that perpendicular one is the shortest one of those lines, that's what we define to be the distance. It's the shortest distance between the 2.
And unless you see that perpendicular box, or you're given some kind of direction that says that that's a perpendicular right there, you can't assume that that's the shortest distance, or that that's the that's the right one you're looking for.
Yep.
You got to know that it's a perpendicular.
Yep.
So shortest distance between a line and a point is a perpendicular, guys. Pretty easy to do.
Yep. Yeah. All right, and that's it. That was just those 2 slides, and so we're still combining the right angles with what we've been talking about, and then this is new here. And we're done with this chapter.
Yep.
So we only spent, 4 sections in this chapter, and we're out of here. Going on to chapter 4, which is a biggie.
Yep.
Chapter 4 is a major chapter in geometry. And
Start getting some shapes.
Starting to get into proofs.
Proofs, that's right.
Proofs of triangles and so on. Yep. So
we look at triangles like you've never looked at them before.
you'll be amazed at what how many different properties triangles have. Triangle's such a basic shape, but it is amazing how many properties a triangle has. So.
Yep.
All right. Okay. We'll see you guys in class.